Hey, I'm Thomas, and this is day 13 of 100 Days of Code in IoT Challenge. Yesterday, I showed you how to read the data from DHT11 module that is a temperature and humidity sensor. Today, I'm going to make use of this data to control an electric heater using the relay device that I've built in the past videos. Link in the description. So yeah, let's just quickly move to the code and continue working on it. So let me just terminate the task of the serial monitor, and I'm gonna go back to the yesterday's project. So I'm gonna go to open recent, file open recent, and hello world 123. This is all the code from the 100 Days of Code challenge. And right, okay. So we're gonna modify this relay controller to, instead of being time-based, I will make it a temperature-based, right? So temperature is going to control the relay now. But before I start writing the code and before I add the library to read DHT11 readings, I need to organize this code a little bit, right? Because it's quite a lot. We got almost 250 lines. So first of all, the event dispatcher that we use, that could be separate file, right? So I'm just going to create this file here, event dispatcher, HPP, gonna use modern C++. And I'm moving it there. I don't think it needs anything else yet. There's no headers required for event dispatcher, I think. However, what we're gonna have to do is to include it. So that's one thing. Another thing, that would be the Wi-Fi manager. That can also be a module on its own. Yes. So Wi-Fi manager .hpp, again pragma once, so we make sure this is included only once. However, this requires event dispatcher as well, so let me just include it there. Okay, that should solve the issue. Yeah, and what we're gonna have to do here is to include Wi-Fi manager. What we can do here though is, yeah, we could completely get rid of all of those Wi-Fi dependencies from here and move them to Wi-Fi manager, but that requires a small modification. I'm gonna show you in a second. So this will go here, and this would also go here. So that would just require Wi-Fi manager, and Wi-Fi multi, that would be something that is required by Wi-Fi manager only. So what I could do is to define it here, but then that also means I'm gonna have to move these lines to Wi-Fi manager. Ideally, that would be constructor, at least for now. So that would be constructor. We've got access to Wi-Fi multi. Ideally, we would make it a dependency. Yeah, this is not very clean. So essentially, better idea would be to make it dependency. So that would do that would be Wi-Fi multi equals Wi-Fi multi. So we could just use Wi-Fi multi here. And that would be, what it was run, I think. No, it was at AP. And that could be just taking the config apart from dependencies, so it have SSID and password. So now we take SSID and password in the constructor, as well as Wi-Fi multi and even dispatcher. So Wi-Fi multi would be still created here. I'm just gonna do it right before the Wi-Fi manager instance is created, so we can pass the Wi-Fi multi as well. Let me just change the name of this variable and just address there. And also what I need is the SSID and password. So that would be the constants that we have, SSID and password. So that actually requires us to include Wi-Fi multi here as well. Okay, that I think is a bit cleaner. There's still dependency on Wi-Fi, on the Wi-Fi, the general Wi-Fi module, but for now I'm just gonna keep it like this. Okay, so we got everything included here. And what I can do now is, hang on, did I copy it? Yeah, I've already removed it from setup. Okay, I'm going to compile it now. Okay, a few issues. Let me have a look. So Wi-Fi manager, add access point. Because this is a pointer, I need to change. I need to change this symbol, the dot symbol, to the arrow. This one should be also Wi-Fi multi-run. Right. So that's one thing. Let me compile it again. And there is one more thing that is not working, and this is the password. Something wrong with the constructor in here. So I got SSID and password. Even dispatcher is the second one. Okay, that is because the Wi-Fi multi is the first one and dispatcher is the second one. Okay, compiling again. Okay, and that works. So yeah, now it's a little bit better organized. There could be more modules. I could extract more parts of the code, but I'm gonna keep it for tomorrow. So the next step is going to be connecting DHT11 on the relay controller board. So let's move to the breadboard view. Okay, so I'm going to disconnect the wires and DHT11 module from here, also USB, and we're going to connect it to this board. So I'm thinking about somewhere here. That's gonna be safer. So just gonna stick the DHT11 here. Let me zoom out a little bit. Okay, so we have DHT11 connected here. And now I'm gonna take the yellow wire and we're gonna have to pick a different pin than D1 because D1 is already connected to the relay module here. So the one I'm going to connect the yellow wire to is going to be, let's say, D6. So D6, and I'm gonna connect D6 to the digital pin of DHT11, which is the middle one. Not sure if it's visible. That's gonna be the middle one. And now plus and minus. So the plus, that's gonna go to the 3v3. There is one free pin. And then I need to connect, I actually need to get a longer wire because this one is too short. So I'm gonna take this wire and connect the ground, the minus on DHT to the ground on the board. Okay. So that makes a connection of the temperature sensor. Right. Okay, because first of all, I'm gonna be working with the USB power supply. I'm just going to disconnect 3v3 from the plus rail that is connected to the power supply module. And I'm gonna connect USB. Okay. So now to the code. Okay, so first of all, I'm gonna open PlatformIO, libraries, type in DHT11 and install the same sensor library we installed with the other project. Going to add to the project and pick the hello world 123 and then press on add. Okay, so the library is added. So I've got everything that is required to start changing the code of the time-controlled relay device and make it temperature-controlled instead. However, before I do that, since this function, send HTTP request, is now event-based, I think it would be better if I give you a little bit overview and explain the implementation of it that I'm planning to do. So I've got two diagrams. One is the main overview that just shows the ESP8266 in the center as a decision maker, right? On one side, it pulls the temperature from DHT11, the temperature sensor, and on the other side, we've got this API endpoint that is a temperature, and the data from it is also being pulled by ESP. And then inside ESP is going to do the comparison, and depending on the outcome of the comparison, it's going to either switch on or switch off the relay. And this is also shown here in the flowchart. So this chart is about the loop function, right? In the loop function itself, we've got three main operations. So one is to get the temperature. This is sort of gonna happen eventually. I'm gonna talk about this in a second. Then we got the DHT get temperature that is from the sensor, and this is assigned to a global variable, sensor temperature. We got the comparison between sensor temperature and desired temperature, and we switching relay on or off depending on this comparison. Basically, if the sensor temperature is lower than the desired temperature, the heater needs to be switched on. So, therefore we switch on the relay. And that just continues, right? It happens on and on. However, since, as I've already mentioned, API gateway client get temperature, making the request is non-blocking. So I have to put a safety mechanism on it to not, first flood the API gateway with so many requests, right? Because loop, happens very, very often. And other thing, I think, ESP could run out of memory if we didn't check if the request is not already in progress, right? This is very important. So I'm going to check if request is in progress, and only if it's not, then the request is made, the status code is checked, and only if the status code obviously is 200, this is going to dispatch an event, temperature received. It's going to pass the temperature received from the get temperature endpoint. So there's going to be a small modification to events dispatcher to handle that. And here we've got the listener, which is super simple, right? It is essentially another global variable like sensor temperature. It's going to be called desired temperature, and it is set on this listener, on this callback. And this is what happens, right? So this is more like eventual. This is probably not going to happen on every single loop iteration, right? It's going to be every n time of the loop iteration, right? Okay. I'm gonna need to set some initial value to the desired temperature because, at the beginning, we're not gonna have it, but I might figure something out. We'll see when I get to the code. Okay. So this is another just last thing, which is this decision-making process here. It's just going to do it all the time, right? Regardless of if this works or if this works, it's just going to continue. And details about that I'm going to show you in the code that I'm going to go back to now. I think I'm also running out of time, so I'm just going to modify the endpoint because this is going to be quick. We just want to have a test data for now. So I'm going to open hello from IoT API. That's the Golang serverless application, right? For those who are not familiar with it, the link, I'm gonna put the link in the description, how to write this code and what this code does. Okay, so first of all, I'm going to open the serverless file, serverless YAML, and I'm going to modify, or maybe I just add a new handler. This is going to be better, so we keep the backwards compatibility. Okay, I'm going to call it temperature. And there's going to be handler bin temperature events single HTTP event with the simple path, right? Temperature. I think what we want to do is keep it like that, yeah. Temperature. And method this time is going to be get. Right. Okay, also I have to modify the make file to build it. So that's going to be also temperature and temperature here. And the last step is going to be copy paste the hello folder and rename it to temperature. So that was for the folder structure and configuration. Now a slight change in the code. That is going to be the response from the server. We don't really care about body since there won't be any data on the body. And there's not really gonna be any JSON. So that makes it much easier for the body that we're going to return. So this all is probably not, it is not required. And right now, I'm going to set the temperature for 24. So this is going to be more like a mock service, right? Yeah, at the end, I'm going to modify this code to be more functional, right? We have like an actual temperature control center, something like this. I'm thinking about storing this data in the S3 file. So you could basically set the temperatures for the different times in a day, right? But, that's the future for now. I want to keep it simple because, as I said, running out of time for today. Cool, yeah, so what happens here is very simple. So as you can see, we just return a response. The status code is 200 and the body is just 24. I'm not returning JSON. So the content type actually is going to be, I think that should be text plain. Let me just confirm that. Actually remove the content type completely. We don't need any headers here. So just the body 24. The reason I'm not using JSON is simply because on ESP8266 site, there is a library required to parse the JSON. It takes a little memory, but for now, I would like to keep it simple. So this is just gonna respond in a plain text 24. Okay, and the last step on the whole serverless service is going to be deploy everything. So let's see if we get this built and deployed. Okay, done. Let me copy the endpoint. So that's the new endpoint. I'm gonna copy it and paste it as a comment to. Oh yeah, I need to go back to the hello world 123, which is the time controlled relay device. Just here, the end of file, I'm going to paste this URL and quickly curl it. So, no, this is not what I want. No, it's also not what I want. This is what I want. Yeah, so we got 24. That works. Okay, and this is gonna be it for today because it's well over 15 minutes now. Again, I cannot really do 15 minutes. I usually run over, so maybe I set the new time limit. I'm not gonna set it now because if I set it now, I probably run over on the next video. Yeah, but essentially this is it for today. Thanks for watching. I hope you liked it and this is interesting for you. And if it is, please subscribe to my channel. If you have any questions or feedback or you have any suggestions for the projects for me to do, leave the comment. And all the links to the code, parts, components that I'm using, you can find in the description of the video. And also all the previous projects that I referenced in this video. Cheers, bye.